Like many barrier islands, Fire Island protects coastal communities by acting as a buffer against storms. However, this island ecosystem is as vulnerable as it is beneficial. Overwash, erosion, and the threat of global warming are all factors that will determine the future of this important and beautiful island.
Hello, my name is Mallory Jones.
And I'm Dave Carmen.
And this is Ecology Now. Today, we'll be documenting Fire Island, a barrier island. This long stretch of narrow sand runs parallel to Long Island on the northeast Atlantic coast.
The majority of this island is a national park that was established in 1964. What is a barrier island?
Good question, Dave. A barrier island is a formation of sand that's primarily shaped by wave patterns, changing sea and sediment levels, as well as storms. And actually, in the past 7,000 years, Fire Island has shifted 2 kilometers towards land.
Say, Mallory, are you ready to explore?
Yeah, let's go.
Piping plovers, an already threatened species in the northeast, skitter around Fire Island, scavenging for worms and snails to bring back to their nests. They can be found nesting safely above waterlines along the coast. They are so damn cute. With sea levels predicted to rise up to 2 meters over the next 100 years, piping plovers on Fire Island will have to confront flooding and displacement. Because of its low elevation and limited sediment supply, Fire Island will struggle to accumulate enough sand to outpace sea level rise. Luckily, volunteers on Fire Island have installed protected nesting grounds for piping plovers and survey plover populations to ensure that they are stable. Fenced-off areas keep island visitors from disturbing the fragile habitat of these birds.
It is chaos. The superstorm battering the barrier islands.
Hurricane Sandy hit Fire Island on October 29, 2012, with a diameter of almost 2,000 kilometers and wave heights that reached as high as 9.6 meters. That's almost as tall as a 4-story building. Because of the high waves and rapid winds, Fire Island experienced severe beach and dune erosion, large-scale overwash, and breaches in 3 locations.
This is not a time to be stupid.
The sediment volume of the beaches and dunes decreased by 54.4%, and the elevation of the dunes and beaches dropped by 1 to 3 meters, leaving the island highly vulnerable to further erosion and overwash. A series of 7 harsh winter storms hit the shoreline after Sandy, causing even more erosion. Between November 2012 and mid-March 2013, Fire Island's shoreline eroded an average of 21.4 meters and shifted about 60 meters towards land.
Here we are at the breach that was caused by Hurricane Sandy, a high-intensity storm. The cyclone diameter was 2,000 kilometers. And here we are. And here's the damage.
The island breached at 3 locations. First location closed naturally. Second location, humans closed it a few weeks after the storm. This is the 3rd location. They left it open because of the ecosystem benefits, which include improved water quality, improved circulation, and new habitat for animals.
Welcome to the breach at Fire Island.
Understanding the rate of dune recovery after storms can reveal how various areas on Fire Island will be affected by future storms and rising seas. Dunes recover as sediment from offshore sandbars is transported to the dune tube over time, followed by the recovery of plant species. Dune recovery can take years to decades, depending on the size of the dune that was eroded. Small dunes recover faster than larger ones because it takes less time for sediment to build up.
During storms, waves can carry over the island and carry sediment into back barrier regions and cause overwash fans. These overwash fans can lower the elevation of the island, which can increase sensitivity to lower storm surges. As you can see, the sediment up here in the forefront of the beach is well mixed and round. But up here, the sand that was carried by the waves is muddier and actually more nutrient rich, and it's a little tougher, as you can see.
Sand dunes on Fire Island are constantly being eroded over time by winds, wave activity, and storm events. Erosion is more common on narrow areas of the island that have lower dunes and experience more overwash. Human interference also influences dune erosion. The west side is the most developed area on Fire Island. As a result, it is the target of many projects aimed at restoring beaches and dunes.
Beach scraping is one such project. During this process, sand is bulldozed to the back of the beach in order to enforce the base of the sand dunes. It is common for dunes that have been artificially altered to be closer to the water, and to be taller than natural dunes as well. These qualities make them more vulnerable to erosion. Another common technique is called beach replenishment. This is when sand is added to the beach in order to increase its volume.
Although these practices give homeowners who live close to the water a sense of security, they tend to be ineffective in combating erosion in the long term because the sand that has been added is not compact and can quickly wash away. This sediment can end up on beaches in less developed areas of the island. A more effective combatant against dune erosion in the long term is right underneath our feet.
Strong winds, saline spray, and overwash are just some of the stressors that plants on Fire Island must endure. However, these plants have adaptations that allow them to survive in such harsh conditions. For example, woody species such as Morella cerifera obtain nitrogen from nutrient-poor sediment by forming a symbiotic relationship with nitrogen-fixing bacteria. The roots trap and stabilize sediment, leading to an increase in island elevation. Some species are stimulated to grow when they are buried, allowing sediment to accumulate even further. Over time, these plants have the potential to alter the landscape of barrier islands and increase their resilience to storms. They can even facilitate the introduction of new plant species and a more diverse island plant community.
Plants can alter the physical qualities of the sediment in which they grow. For example, they can increase the organic matter and moisture content of the soil around them. The roots of plants increase cohesion among soil particles of sand as well. These changes in soil composition and structure can impact a dune's response to erosion. Scarps are small ridges or cliffs that form as a result of erosion. When a scarp forms, the plant root system and more stable sediment holds particles together. As a result, the ridge will be much less likely to fall apart and wash away.
When standing on the beach of Fire Island with miles of sand and water surrounding you, it's easy to feel as if you're standing on the edge of the earth.
If you look closely, you might see the dorsal fin of a dolphin skimming the water, a family of deer hidden in the trees, or perhaps some undiscovered treasure that is washed up on the shore.
Gaining an understanding of the ways in which the dunes and beaches change over time is more important now than ever, as rising seas and more frequent storms threaten to wash away this valuable and unique island for good.